So my first question is this pretty basic question. Why did you choose to go into engineering?
It's actually not that basic a question because I didn't choose to go into engineering. I'm kind of a happy accident. And in fact, when I was your age and finishing high school, I was good at math and science. And, occasionally people said, do engineering, but there really wasn't very much, very few people in my school had done engineering. I went to an all-girls school. Very few women went into engineering. And I really didn't know very many sort of professional engineers. And so from what I had been able to determine about engineering, it didn't sound that great. And so I went off to Cambridge to do physics. I discovered that physics at the college level wasn't the fun stuff that I'd enjoyed in high school. And I actually discovered that material science encompassed a lot of what I had enjoyed in physics in high school. And so I ended up, majoring in that. And while I was doing that, I discovered that I really liked extractive metallurgy. And I went off to Imperial College to do a master's in extractive metallurgy. And kind of at the end of it, I discovered that that was an engineering degree. So I really followed my interests and ended up in a program that turned out to be engineering rather than ever making a conscious decision to do engineering. I mean, I can now look back and realize, oh yeah, I think like an engineer, I approach life like an engineer, but I never consciously chose it. I just did what seemed fun.
Okay, thank you. Another question, what were your school days like in college?
Oh, so Cambridge was, this is sort of undergraduate. They had a very, very different system. It had 3 terms every year, which were only 8 weeks. And we had classes 6 days a week with lectures in the morning, big lectures, with hundreds of people, until my final year when I was specializing in materials. And then labs would be in the afternoon. And Cambridge has a tutorial system whereby you, in very small groups, meet with either a faculty member or a postdoc and discuss sort of basically problems that appeared in previous exams. And there was a lot of partying, a lot of fun, a lot of, drinking coffee with people and, sort of, pondering the meaning of life and everything else. And that was a lot of fun. But graduate school for me was very, very different and very structured, going into the department, spending all day there, basically kind of, particularly when I was doing a PhD, I sort of approached it much more like kind of a 9 to 6 job in the lab. And I was sort of lucky in that my circle of friends from Cambridge, a lot of them moved to London. Most of them were working, and I was doing a PhD. And so a lot of the social activities basically were translated and it was sort of socialized in the evening. So it was much more structured. Structure worked well. I figured early on that it was a good idea to be in the lab at the same time that the professors were around, because I could sort of ask questions and get assistance, but also they got the idea that I worked hard. I honestly had, when I was in grad school, there were a lot of students in my group were from Latin America, and they tended to be kind of night owls, and they would come into the department about 4 p.m. and then work late into the evening. But they weren't around much when the professors were around. And so they sort of suffered from a reputation of not working hard. And that I could see was a problem, rather than sort of having discipline and just working, very regularly.
Can you think of any challenges in your career and how you overcame them?
For me, one of the biggest challenges was that the preparation in math that I had in high school was not adequate. And so the British educational system was so different from the American system that there isn't really a direct analogy. I had 3 years of calculus by the time I went to college, but it actually wasn't adequate because they assumed that I'd done more calculus than I'd done. And I, probably because I was partying too much, I never really sort of mastered vector calculus. But that really was a challenge for me. And the way that I overcame it was that I went into branches of material science that really didn't need the math that I wasn't able to do. So that's a rather sad story. So I made a career basically that didn't require material that I was missing. But to me, it really underscores the importance of building up your foundation. And then, the other challenge, which, I can really see in retrospect, is that, for so much of the time I was the only woman. When I went to grad school, I was the only woman in my program. When I became a faculty member, I was the only female faculty member in my department for 19 years. I was actually department chair before there was another woman. And it just meant that it was often kind of lonely, and I overcame that challenge by sort of seeking out women, doing other programs. And, in fact, I think was a lot friendlier with female staff in my department than most of the professors were. And because of that, that actually became an advantage. In one of the things that I don't like about academia is that in many institutions, there's what I actually frequently refer to as academic feudalism, where faculty are sort of higher up on a sort of pedestal than staff who aren't in academic titles, which drives me crazy because everybody's really important for the success of students. And in the university, everybody's there for the students. But a lot of staff members have told me that they really appreciated my respect for them and appreciation for what they did. And so as a result, as an administrator in universities, I've enjoyed a working relationship with staff colleagues that I think many administrators didn't have. And I think that stemmed from the fact that, early on, sort of the staff were my friends. And so, of course you treat your friends with respect.
Could you describe your career or your work and what activities you kind of partake in on a day-to-day basis?
During term time, my work very much revolved around teaching and preparing for classes and, doing office hours and so on. And then the rest of my focus was on research. When I was a younger faculty member, I spent a lot of time in the lab as techniques evolved and I got busier doing other things. I delegated more to my students, but I still, sort of enjoyed hearing from them, on a very regular basis what it was that they were doing. Different faculty members have very different styles to supervising graduate student research. Some are very hands-off. Others are very sort of managerial. I mean, I know people who meet with each student first thing in the morning and tell them exactly what they're going to be doing, and then check in the evening to, you know, find out what they discovered. And I have avoided that because I think that when you're overseeing doctoral students, your most important job is to teach them how to do research. And if you are managing them as though they were technicians, they're not really learning how to do research. You know, they're more learning sort of basically not thinking for themselves, which, you know, I think is a problem. So you know, I think that I struck the perfect balance, but of course, different people have different ideas as to what that perfect balance actually is. And then I also, there's a lot of sort of behind the scenes activities that academics do, where it's put into this big bucket called service, which involves everything, you know, all sorts of different committees, some of them university policy. I was very engaged in our academic senate. I led that for a couple of years. Serving on exam committees for PhD students, just meeting with other people's students, talking about technical issues. It's really hard to put your finger on it, but sort of really being busy the whole day.
What is one thing in your career that you're particularly proud of?
I suppose in terms of my research work, the thing that I really do feel very proud of is the fact that I've worked in the area of mining and resource production, which most people will sort of say, oh, no, you know, this is really bad for the environment. And very early on, I mean, when I was in school, I sort of came to the thinking that as society, we need raw materials. And the fact that they aren't, at that point, they weren't being produced in an environmentally responsible way, didn't mean that you had to stay away from producing, working on production of raw materials. I felt that the big engineering challenge was finding out how to produce our raw materials in an environmentally responsible way. And when I started my career, that was deemed an almost heretical attitude by a lot of people in the industry. And it made me a lot of enemies. I often felt, and in retrospect, I think I was correct, that I would have been elected to the National Academy of Engineering much earlier, had it not been for the fact that there were a lot of people in the mining industry that didn't want me because I preached a gospel of environmentally responsible production of materials. Attitudes have changed, and I am actually, I think, now recognized as a bit of a pioneer of the concept of environmental compliance in materials production, which is not to say that we're fully there, but I am proud of the fact that I didn't compromise on my ideals. And in many respects, I feel like I helped move the needle towards pointing society towards the need to actually be responsible for what it is that we're doing for producing raw materials.
Thank you so much for the advice and information. It was nice interviewing you.